Good morning, class. We are looking at statistics practice test number 1. Module 1 covers chapters 1, 2, 3. Here's chapter 1, Introduction to Statistics. So we have mainly definitions. Chapter 1, Introduction to Statistics. Question number 1, true or false? The value of variance and standard deviation is never negative. That's a true statement. It's a true statement. These are absolute quantities that is a measure of variation of values, of all values from the mean. It can be zero. So the proof is in the formula, everybody. Population variance uses sigma. It's a Greek letter, so sigma squared is summation of x minus mu quantity squared over capital N. And we really want the standard deviation, which is the square root of that. So the standard deviation is the square root. Sigma is the square root of summation of x minus mu quantity squared over n. And as you can see, x minus mu, whether it's positive or negative, when you square it, becomes positive. Summation of positive numbers is positive, and so is n. So that proves why it's positive. Of course, x minus mu can be zero, in which case, if the sum is zero, you end up with 0 over n, which is 0, and square root of 0 is 0. So it could be 0. So therefore, it's never negative. The sample, we use s squared instead of sigma squared. S squared is summation of x minus x bar quantity squared over n minus 1. And this is the expanded format. You can use that or this one, n summation of x squared minus summation of x quantity squared over n times n minus 1. That is the variance for a sample. We discussed the difference between a sample and a population in a moment. And the sample standard deviation, you just take a root of each one of those. And again, it shows that the value is non-negative. Now let's go to some definitions, everybody. What kind of variable weights of a bears is quantitative or qualitative? So let's discuss the issue. Quantitative and qualitative variables are two types of variables usually used in data analysis and statistics. Quantitative variables, also known as numerical variables, represent measurements of quantities that can be expressed numerically. So this is a quantitative variable. Weights of bears gives numbers that represent counts or measurements, according to this definition. What kind of variable gender of bears is? Qualitative, quantitative, or qualitative? Well, we've given the definition of a quantitative. Let's look at the definition of a qualitative. Qualitative variable, also known as categorical variables, represent characteristics or qualities that do not have a numerical value. These variables are typically divided into categories or groups. Examples of qualitative variables include gender, marital status, or types of cars. In summary, quantitative variables involve numerical measurements or quantities, while qualitative variables represent non-numerical characteristics or categories. So clearly, gender of bears will fall into this category. So it's qualitative. Gender of bears is distinguished by non-numeric characteristics. Define population and sample in statistics. Population is the complete collection of all elements, scores, people, measurement, etc. to be studied. Sample, a sub-collection, simply a portion or fraction of elements drawn from a population. So in short, Population represents the whole, sample represents a fraction or a portion. More precisely, population. The population refers to the entire set of individuals, objects, or events that possess certain characteristics of interest and are the subject of statistical investigation. However, populations can be large and sometimes impossible to study in their entirety due to practical limitations. Sample. A sample is a subset or small representative group selected from the population. It is portion of the population that is chosen to represent the whole. In summary, the population refers to the entire group of interest, while a sample is a smaller subset selected from the population for analysis. Statistical analysis are typically conducted on samples to draw a conclusion about the population from which they were drawn, simply because we don't have access to the population or we don't have the resources or the money to get to the population. That's why. The value of the middle term in a ranked data set is called the median, everybody. So you rank them from normally from smallest to largest. You can go the other way around, but from the smallest to largest, the one in the middle is called the median. We'll discuss this further later. Given any data, how do you find the mode? Mode is the value that appears with the greatest frequency among the data. A data set can have one, more than one, or no mode when all numbers appear with equal frequency. So basically, you rank them. The one which happens the most is the mode. And we could have more than one. That's why we can have one, it's called unimodal, or otherwise. It will be multimodal, maybe more than one. True or false? The number of chairs is considered to be a continuous variable. That's a false statement. The number of chairs is not continuous. We cannot have 1/4 of a chair as an example. So let's look at a couple of definitions. Discrete. Data result when the number of possible values is either a finite number or a countable number of possible values 0, 1, 2, 3, etc. Examples: number of students in a class, number of cars in a parking lot. So those are discrete variables. Continuous. Data that can take any value in an interval. Data result from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruptions, or jumps. Examples: the weight or height of a person. So in short, there is no gap. You could have a fraction. And basically, that would be the difference between the discrete and continuous. Discrete is countable. What is a Pareto chart? What does each axis represent? A Pareto chart, named after Vilfredo Pareto, is a bar graph for categorical, also known as qualitative data, similar to histogram for quantitative data. Histogram is for quantitative, Pareto chart for qualitative data. A histogram for quantitative data, which is used to summarize discrete or continuous data that are measured on an interval scale. The vertical scale represents frequencies or relative frequencies, and horizontal scale represents different categories. Bars are arranged in descending order to emphasize the order of impact. So in short, histograms and Pareto charts are very similar. Pareto chart is for qualitative and histogram is for quantitative. Define a parameter and a statistic. Parameter, a numerical measurement describing some characteristics of a population. Statistic, a numerical measurement describing some characteristics of a sample. Define random sample and simple random sample. Random sample. Members of the population are selected in such a way that each individual member has an equal chance of being selected. Simple random sampling, sometimes they call them SRS. Of size n, subjects selected in such a way that every possible sample of the same size n has the same chance of being chosen. The idea is that in the case of a random sample, everyone has the same chance of being picked. For example, in a class of 30, every student should have a chance of 1 out of 30. That's a random sample. But in the case of a simple random sample, you look at a specific sample size. So you want to pick a sample of size 2 or 3 or 4 or 5. Let's say a sample of 5 out of those 30. Now, each sample of size 5 must have the same chance. Of course, you use combination to figure out how many different samples are available. Sample of the same size. Define the following types of sample: systematic, convenience, stratified, and cluster. Systematic sampling. Select some starting point, randomly, of course, and then select every kth element in population. Example, in a population of 50,000 people, a statistician selects every 100% for sampling. But there has to be some starting point, which can be done random. Convenience sampling. Use results that are easy to get. Example, standing at a mall or grocery store and asking people to answer questions would be an example of a convenience sample. Stratified sampling. Divide the population into homogeneous. The subjects within the same subgroup must be similar and share the same characteristics. Subgroups called strata, and then obtaining a simple random sample from each subgroup called strata. Cluster sampling. Divide the population into sections or clusters, non-homogeneous subgroups. Then randomly select some of those clusters and choose all the members from those selected clusters. So it's easy to see how stratified and cluster sampling are different. In the case of a stratified, each group that you choose, the individuals in the group are the same. So homogeneous. So you pick some from this group, some from this group, some from this group, and so on, of course, randomly. In the case of a cluster, you make sure all groups are similar. So if you pick a group, you keep the entire members. So if you pick this group, you keep all those three. And of course, you choose randomly. What are different levels of measurement of data? Give examples. Nominal level of measurement is described by data that consist of names, labels, or categories only, and the data cannot be arranged in some order such as low to high. That qualitative that we discussed, also known as categorical, also known as nominal. Examples. Survey responses of yes, no, and undecided. Eye colors, blue, brown, so on. Political party, Democrats, Republicans, Independent, and so on. Ordinal, so one of them is nominal, one of them is ordinal level of measurement. Involves data that can be arranged in some order, but differences obtained by subtraction between the data. Values either cannot be determined or are meaningless. Examples. Ranks of colleges. Ranks can be first, second, third, and so on, which determines an order. Assigning grades of A, B, C, D, or F, these grades can be arranged in order, but we can determine difference between the grades. I'm going to continue with the same question. The next one is called the interval level of measurement. Interval level of measurement involves data that can be arranged in order, and the difference between data values can be found and are meaningful. However, there is no natural zero starting point. There is no natural zero starting point at which none of the quantity is present. A value of zero doesn't mean the absence of the quantity. Arithmetic operations such as addition and subtraction can be performed on values of the variable. For example, if you look at temperatures or body temperature for that matter of 98.2 degrees Fahrenheit and 98.6 degrees Fahrenheit, the difference does make sense. Years, 1000, there 2000, 1776, 1492. pH, SAT scores, stuff like that. And the last one is the ratio. It's the highest level. Ratio level of measurement data can be arranged in order. Differences can be found and are meaningful. And there's a natural zero starting point, where zero indicates that none of the quantity is present, and that's the key. Differences and ratios are both meaningful. Arithmetic operations such as multiplication and division can be performed on the value of the variable. Examples. Distance traveled, 0 kilometers represents no distance traveled, and 400 kilometers is twice as far as 200 kilometers. Prices of books, $0 does represent no cost, and a $100 book does cost twice as much as a $50. What's the difference between an observational study and an experiment? Give examples. Observational study. Observing and measuring specific characteristics without attempting to modify or influence the individual being studied is an observational study. The researcher merely observes and tries to draw conclusion based on the observation. Example, a study took a random sample of adults, asking them about their bedtime habits. The data showed that people who drank a glass of warm milk before bedtime were more likely to go to sleep earlier than those who didn't. experiment. Apply some treatment and then observe its effect on the individuals. The individuals in the experiment are called experimental units, and they are often called subjects when they are people. In other words, an experiment is a controlled study that aims to determine the effect of one or more independent, also known as explanatory variable, or factors on a dependent or outcome or response variable. Any combination of the values of the factors is called a treatment. The researcher manipulates the independent or explanatory variable and tries to determine how the manipulation influences the dependent outcome or response variable in an experimental study. Example. Another study took a group of adults and randomly divided them into two groups. One group was told to drink warm milk every night for a week, while the other group was told not to drink warm milk that week. Researchers then compared when each group fell asleep. This is an experiment versus simply an observational study. Describe cross-section, retrospective, and prospective studies. Give examples. Cross-sectional study. Data are observed. An observational study measured and collected at one point in time. A cross-sectional study is like a snapshot of a particular group of people at a given point in time. It is used to describe what is happening at that time. Example, a medical study examining the frequency of cancer among a population of different geographical locations. By doing this, any differences among them can most likely be attributed to geographical location differences rather than something that happened over time. Retrospective or case control study. Data are collected from the past by going back in time, data that already exists. Example. Researchers ask participants about their smoking habits over the past 20 years. Then they can analyze any possible correlation between their smoking habits and a disease such as lung cancer. Retrospective goes back in time, uses the existing data. We continue, and the last one is prospective, longitudinal, or cohort study. Data are collected in the future from groups called cohorts, sharing common factors. Longitudinal studies look at a group of people over an extended period. Example. A medical study follows a cohort of middle-aged people who vary in terms of smoking habits to test the hypothesis that the 20-year incidence rate of lung cancer will be highest among heavy smokers. So basically, it's checking to see if those who are smoking get cancer more, especially those who are heavy smokers. That's the case. Followed by moderate smokers and then non-smokers. Example, the Framingham Heart Study began in 1948 and is a long-term ongoing cardiovascular cohort study of residents of the city of Framingham, Massachusetts. So cross-section happens at one point in time. Retrospective uses data that exists already, goes back in time, in other words. And prospective just follows a cohort, a group, way into the future. What is sampling error, non-sampling error, non-random sampling error, and voluntary response sample? Sampling error. Sampling error is the difference between a sample result and the true population result that is the consequence of chance sample variation. For example, if you want the mean of the population versus a sample when you're dealing with a population of, let's say, 1,000 people, and you choose only, let's say, 50 of those, then you calculate the mean for each case. If you happen to have both of them, there should be some differences, and that is called sampling error. Non-sampling error. The non-sampling error occurs due to data that are incorrectly collected, recorded, or analyzed. It may happen by selecting a biased sample, using a defective instrument, or copying the data incorrectly. So some sort of a mistake and error on our behalf. Non-random sampling error. Non-random sampling error is the result of using a sampling method that is not random, such as using a convenient sample or a voluntary response sample. So of course, when it comes to statistics, we have to pay attention with randomness is extremely important. If it's not random, itself can create a problem known as non-random sampling error. Voluntary response sample or self-selected survey. One in which the respondents themselves decide whether to be included. In this case, valid conclusion can be made only about the specific group of people who agree to participate. Needless to say, in some cases, we may have no other choice. So for example, when you're in a place and you ask people about some opinion of theirs, that is a voluntary response, those who want to answer it and those who don't want to answer it. So that's an example of it. What are some characteristics of an experiment? Confounding. Confounding occurs in an experiment when the experimenter is not able to distinguish between the effect of different factors. Common confounders are characteristics of the participants, such as body mass index, smoking status, age at onset of illness, socioeconomic status, educational status, extent of support network, and life events. So when you're checking something, there may be other factors that will be, in some cases, even more effective than the ones that you are checking. For example, alcohol use can result in lung cancer. So this is exposure to alcohol use, and the outcome is lung cancer. But a confounder could be smoking, because smoking and alcohol sometimes, they go together. People who are drinking, they like to smoke. Okay, so one affects the other. Or even worse, smoking can cause lung cancer. We know that. So this could be a confounder. If you are checking the usage of alcohol and the result for lung cancer, a big confounder would be smoking, as an example. Blinding. Subject does not know he or she is receiving a treatment or placebo, which is known as a fake medical treatment, a sham medical treatment. The placebo effect is when a person's physical or mental health appears to improve after making a placebo, or sometimes they call it dummy treatment. Blocks. Groups of subjects with similar characteristics. So these are some common characteristics of an experiment. Let's look at a couple more. Completely randomized experiment design means subjects are put into blocks through a process of random selection. This is extremely important, this randomization. Replication. Repetition of an experiment when there are enough subjects to recognize the differences in different treatments. Of course, this, if the resources are available, is a must. So you replicate, you repeat to make sure the result is what you believe it should be. Sample size refers to the number of individuals or items selected from the population to be included in a sample of a research study or statistical analysis. It must be large enough to display the true nature of the population data and should be obtained using an appropriate random method. Now, again, it should be a decent size. That's the bottom line. However, sometimes there are limitations. Again, there may be not enough individuals available, or again, limitation of resources as mentioned before. Explain some misuses of statistics. Bad samples, small samples, misleading graphs, distorted percentages, loaded questions, order of questions, refusals, that means refuse to answer, correlations, and causality, because correlation doesn't mean causality, self-interest study, precise numbers, partial pictures. As far as the self-interest study, you really have to see the source of the study. That is extremely important. For example, pictographs. Double the length, width, and height of a cube, and the volume increases by a factor of 8. 2 cubed equals 8. To correctly interpret the graph, we should analyze the numerical information given in the graph instead of being misled by its general shape. So this is a cube. This is 10 by 10 by 10. If you double it 20 by 20 by 20, it's 8 times larger when it comes to the volume, as an example. Deliberate distortion, loaded questions. Look at these two questions. Should the governor have the line item veto to eliminate waste? Or the same question, should the governor have the line item veto or not? What do you think is going to happen when we add waste? That becomes a loaded question. In this case, 95% said yes. In this case, 53%. That is a huge difference. Note, if sample data are not collected in an appropriate way, the data may be completely useless, that no amount of statistical training can salvage them. Randomness typically plays a critical role in determining which data to collect. So randomization is a very important part of study, statistical study. A research center questioned 2,000 adults in the US to estimate the proportion of the population favoring death penalty for murderers. It was found that 70% are in favor of death penalty for murderers. State the individual, variable, population, sample, parameter, and statistics. Starting with the population, that would be all adults in the US. Sample, how many of them did we choose to ask, or how many of them did answer? The 2,000 adults in the US that were surveyed. Individual would be just one adult in the US. Variable, what are we asking? Favoring death penalty for murderers. That is the one, is the variable. It's going to vary. You are favoring, that means you're for it or you're against it. Statistics. Now, out of those 2,000, it was found that 70% are in favor. So the 70% in favor of death penalty for murderers in this study is the statistic. Perimeter. Perimeter refers to the population and it is not given. I want you to know that. The perimeter is missing. What would be the perimeter? If we had the result for the entire population of adults in the US and what they think of that, that would be the population. Let's assume for the sake of argument, if we had some way to ask the entire population and we got 64% for it, that would be the perimeter. It is unknown. However, in some texts, they may use this as the perimeter, and this is a wrong way of doing it. It is unknown. So again, I'm mentioning that is unknown. Perimeter is not given. On a normal basis, we don't have access to a perimeter because we don't have access to the population. It's very hard to ask the entire population. So in some texts, they might. So we don't want to, we want to pay attention to the concept. Decide if each of the following describes an observational study or an experiment, starting with the height of the shoppers at the mall was recorded. We're just simply observing. We are not doing anything. Observational study. A drug is given to a group of people and their reaction observed. Definitely, it's an experiment. So we are looking at the people who are taking the drug, and of course, it's being checked versus those who don't. A group of students are told to listen to music while taking a test, and the results are compared to a group not listening to music. Clearly, it's an experiment. The temperature on randomly selected days throughout the year were measured. We're just simply observing. It's an observational study. The gender of children born in January were tallied. You're just observing. You're not doing anything. The growth rate of bacteria is compared before and after adding alcohol. Definitely, it is an experiment.